Hello everyone, welcome to SI UK India webinar. Thank you for joining us today. We are now live with University of Southampton. In this special webinar, we will learn more about studying biomedical engineering and electrochemistry and battery technologies at the University of Southampton. Over to you, David. Your mic is on mute, David.
Sorry. Thanks very much. I hope you can all hear and see me. And welcome to Southampton. I'll speak, as we said, I'll speak a little bit about the Masters in Biomedical Engineering that we are running here at the University of Southampton. And if I can get myself untangled here, I'll share the screen with you. Okay. Great. I hope that you can all see my slides now. So my name is David Simpson, and I'm a professor of biomedical signal processing, having worked in biomedical engineering all my life. And I'm the admissions tutor for the MSc in biomedical engineering. And I work in what's called the Institute of Sun Aberration Research, which is part of the Faculty of Engineering and Physical Sciences. And I'm also linked with the Institute for Life Sciences, all at the University of Southampton. What I'll do is I'll talk briefly about the program and the structure of the program, and about some areas of specialization and projects you might be doing as part of your master's degree. And then talk a little bit about Southampton and why come to the University of Southampton. So let's start with the really important part of the program, which is the students. The program is designed primarily for students who've got a degree in engineering, mechanical engineering, electrical engineering, chemical engineering. We also get quite a few students who've done biomedical engineering and want to go further in this field. We have students with a background in physics, mathematicians, and also some from a more biomedical sciences background. But we have to be very careful, because we are expecting students with a solid knowledge in engineering basics, in maths, in be able to do some computer programming and so on. So we look carefully at applicants from these non-engineering areas to make sure that they can really thrive on our course. It's not designed for students who've got a background in biology or health sciences. We are just expecting too much engineering for you to do well. We also expect good grades, and the reason is obviously for you to be able to pass the course and pass it well, but also because it's important that we have a strong student cohort, because the students are a really important part of your learning. The fellow students who are studying with are really important. You need to be stimulated in the discussions with other students. The enthusiasm that all of you have for the subject will help each other. So the student cohort is a really important part of your learning. And all that, we hope, will contribute to you thriving in the course that we have to offer. Our students come from all over the world, which I think is one of the real strengths of studying in the UK. Here is a group of students from the past. There's somebody from Ghana, from the Arab Emirates, from India, from Jordan, Romania, China, Mexico, Ireland, Palestine, India, UK, China. So they come from all over the place. And I think that makes for a really rich experience of studying with us. The structure of the program is, I guess, the standard structure for master's courses. It's a one-year program, and we start in end of September, beginning of October. with the 2 compulsory modules, Introduction to Biomedical Engineering, which I teach, and Human Biology and Systems Physiology, together with 2 optional modules. And I'll talk about the options on the next slide. So in introduction, what we try to do is give you an overview of biomedical engineering, the different areas of diagnostic technology, therapeutic technologies, assistive technologies, prosthetics, and biomedical engineering in discovery science. We also try to make you aware of many of the questions around biomedical engineering, the societal context. So we have a specialist in health economics talking about more the economic side of biomedical engineering and the way in which the government might approve technologies because they think they're good value for money. We have somebody talking about safety and regulations, somebody else talking about usability, and that's a key element that we emphasize, is that we are designing things as biomedical engineers, we are designing things, we're making things, we're maintaining things for the benefit of the user, for the patients, maybe for the carers, for the clinicians, for the benefit of society and the users. And we must always keep the users in mind as we're developing our products. So after that second semester, which I hope will give you the ethos we want of being user-focused, we then have another compulsory module called Translational Medicine, where the pathway from the ideas, from the designs, to the actual clinical availability, what we call from the bench to the bedside, is developed with appropriate training in the different steps that might be taken in that process. So we hope you develop into an engineer who will come out of the degree program knowing how they can take an idea from the initial concept all the way through to having it as a product for the benefit of the users. And then there are 3 optional modules, and I'll talk about those, as I said, on the next slide. A really key part of an MSc is the project, which counts for 1/3 of the marks and runs typically from about February to September, with most of the work done from about June to August, and then in September it's mainly writing up and finishing the write-up that students have to focus on. We have a very wide range of projects from across our faculty, the different groups doing biomedical engineering, research and development across the faculty, but also beyond. We have projects that involve health sciences. Physiotherapy is one of our strong collaborators. We have projects that are focused more in medicine. They cover both the sort of the mechanical engineering side of things, but also aspects of electronics. One key feature of biomedical engineering teaching is doing it's an interdisciplinary area. And we want to make sure that that is really present in the teaching. So we have contributions among the lecturing staff from medicine. Human biology and systems physiology is taught by people from medicine. Translational medicine is taught by somebody from medicine. In my module, for example, we have students from, we have lecturers, guest lecturers from health sciences, from medicine, and so on. So we want to make sure that you are familiar with that environment. We also make sure that at the beginning, you actually meet potential users of the technology. We have somebody who has had a stroke who speaks about what he does and what his experience as a patient was and what technologies he finds useful. We have somebody else who is blind speaking about her experiences and what she needs in her daily life, and in what way we might be able to contribute to improving her life. On the right here, you can see some pictures of wheelchairs for neurodisabled children that were developed by one of our guest speakers, who designs these sort of systems for patients, for his clients. In fact, this was an idea that he developed and as a prototype, and now a company has taken on and is selling. So again, as I said, we focus on it being user-centered in our teaching and in hopefully the ethos that our graduates come out with. So optional modules. There is a long list, and these are not all the ones that are available to you. It depends partly on what your background is, which ones you might want to choose, where your interests are, but it covers robotics, it covers sensing, it covers implants and devices, orthopedics, signal processing, imaging, flow, materials, computational methods. Many different options are available to you. And we provide you with support to help you in choosing which ones might be the most appropriate based on your interests and based on your background. We have a personal tutor system where every student is allocated a tutor to whom they can go and with whom they can discuss what their preferences would be and where their strengths are and where their interests are. Here's a list of projects that we're running this year with our students. So the students chose these projects from a big list, or they proposed some of them themselves. And again, it covers a huge range, reflecting the huge range of interests that we have within within biomedical engineering at the University of Southampton. One of my projects is assessing blood flow control in the brain, where we've got some data from colleagues in the hospital. And we're analyzing these with using Doppler ultrasound to record blood flow in the brain, and then relating it to changes in blood pressure. There is quite a bit on orthopedic biomechanics, bone fractures. There's work on auditory implants or cochlear implants. There is work on auditory evoked potential, so measuring the responses of the brain to auditory stimulation. There are projects on imaging. There are projects on microswimmers, or tiny robots, if you like, that might be used in future biomedical applications. There is analysis of breathing patterns. There's low-cost devices for a color spectrum analyzer, models of limbs and prosthetics. So there's a big range of projects that are available. These are the ones that the students chose. There's an even bigger range of projects that were available for them to choose from. Right, so we have also my colleague, Professor Marcus Heller, who leads this biomedical engineering program, is professor of orthopedic biomechanics, and they do a lot of work in trying to understand movement patterns and predicting forces and movement in different parts of, in this case, the lower limb. He works a lot with Martin Warner, who is based in health sciences and is also interested in sports and in movement analysis. They've got a research center on arthritis. They look at optimizing implants. So this is a hip replacement. They look at movement patterns after replacing joints. They've got a system for measuring movement patterns by having little reflectors placed on the skin, and I think there's 12 cameras, which they can then in 3D detect the movement patterns. And in your MSc project, you may well end up having to work jointly with people in health sciences or in medicine to collect data and analyze that data. Another area that Bram Sengers works in is modeling physiological flows. He is very interested in the physiology of the placenta and the way that nutrients, etc., get exchanged in the placenta, working with one of the professors from the Faculty of Medicine and doing, as I said, doing fluid dynamic modeling. There is a lot of work on cartilage. Martin Stoltz does work on imaging cartilage, and also there's interest in engineering synthetic cartilage to replace damaged tissue. Okay, so that's some of the projects and the specializations that we have here, but the range is wide. And when you come, you will see much more of the range of interests we have, and the lecturers and professors who are working in different fields, and you can choose within your skills and interests in which direction to go. Of course, all the courses are for the sake of interest, but also for the sake of, we hope, giving you access to a strong career. Our students go to many different companies. Here's a couple who, Harry, he is working in a pharma company in Oxford. Shiana is working in a healthcare company back in India, just as examples. And there's a wide range of industries that our students go to. A lot of them also carry on and go for a PhD. Some of them with us, some of them going to other universities to continue their studies. And we hope that the training you get with us will prepare you both for working in industry, for working in research, and also for working in hospitals, although for hospital work, obviously, you may need additional specialized training, especially in the area of safety. Right, so Southampton. As you've probably already seen, if you've looked at us before, we are right in the south. Here, this red pin is where Southampton is. It's about 1 hour from London. Being in the south has got one advantage: the weather is relatively better than in some of the more northern parts of the UK. There are strong transport links. It's a buzzing city centre. It's a small city with about 230,000 people. It's friendly, it's lively. One thing that I like about Southampton is you can get out fairly easily. There's a nature reserve just 20 minutes or so by train from a big national park, about 20 minutes by train from Southampton. There's a lot of green space. It's by the sea. Well, there's a big port there. We haven't got a very nice beach close by, but you can get down to the water fairly easily. It's got strong history. It's a great place to go sailing if that's something that might interest you. And there is a lot of culture that is of interest, in shopping and so on. So it's a buzzing city. Why the University of Southampton? It's ranked about 90th in the QS World University Rankings for this year, and it's ranked 75th for mechanical engineering. And our program is developed around mechanical engineering, though it's not restricted to mechanical engineering. We have a lot of links with electronics also. It's a member of the UK Russell Group, the research intensive universities, And the benefit of that is that you will be working with people who are at the forefront of research in our field. It's, by our standards, a reasonably big university, 23,000 students, with strong links in industry. A lot of us have got collaborations with industry. I work with a company in Denmark that develops methods for testing hearing. Previously, I worked with a company that was developing methods for measuring heartbeats in fetuses. So basically trying to disentangle the heartbeats of fetuses from the heartbeats of mothers when you record from the belly of the mother. We are, I think, University of Southampton is especially good at linking across the disciplines. There is a lot of collaboration between engineering, maths, physics, medicine, health sciences, biology. And there's an ethos around the university, an encouragement of such collaborations. And there's many different schemes with the Institute for Life Sciences and joint buildings and joint staff and so on. And that's something we're trying to strengthen even more. And of course, there is also the graduate immigration route. If you come to us now, you will be able to work in the UK for 2 years afterwards. So there's good reasons to come to us. We have, I think, a thriving program, an interested and engaged student cohort, and friendly staff. And I think we provide you with a very supportive environment to get the best learning for you. And I hope you'll be able to join us. I think we're taking questions at the end, but please feel free to send me an email also if you have any questions. Thanks very much.
Thank you, David. Now we have Guy, who will take over and tell us more about this webinar.
Hello, everyone. I hope you can see my slides. Is that okay, Deepika?
Yes.
Perfect. Okay. Thank you very much. Okay, so I'm going to give you a brief presentation on the Master in Electrochemistry and Battery Technologies. And just as a way of kicking off the subject, I've got a couple of images here to show you the sort of investigations that we carry out in research and development around batteries. So here you've got a sodium-ion battery, and you can see the movement of the ions during the charge and the discharge, and the way the ions are intercalated in the cathode material or inserted in the anode material. And then on the right-hand side here, I've got another view of a sodium-ion battery, this time where all the components that make up the cathode, the binder, the electrolyte, the anode, have been exploded, just to give you an idea of the sort of chemistry and material science that we are investigating in our research, but also in this particular master. So a lot of the principles and jargon I will be using later on refers to this sort of chemistry, and it's really a case of understanding all these processes to really understand how a battery works, why a battery fails, what determines the lifetime of the battery. But also, you need to understand that to select the right battery for the job. In the next slide, I'll just introduce myself. So I'm an associate professor of electrochemistry, but I'm also the director of the MSc program in electrochemistry and battery technologies, and I'm the admission tutor for MScs in the department. I'm also running what we call the Southampton Electrochemistry Summer School. This is a course that has been running since 1969, and I've been involved with this course for a very long time. In fact, I'm an alumni from the Southampton Electrochemistry group. I did my PhD here before going to the US to do to take my first job there, and then I came back to Southampton. So I know what it's like to be a student here, and I also know what it's like to be a teacher here, a lecturer. And I must say my experience of Southampton coming from French universities has been very, very interesting. I've been able to see all what is on offer here, and I've really liked being a student here and being a member of staff. My research spans different areas of electrochemistry. I'm interested in micro and nano electrochemistry, but also get to do some modeling and simulations of electrochemical processes. In fact, I teach this module for this master, and I have a particular interest in the study of the oxygen reduction reaction, which is a very important reaction for fuel cells and also now for some batteries, lithium-air batteries in particular. And I have a particular interest in the application of electroanalytical techniques in sensing, and in particular in sensing in oceanography, which is an extreme challenge, because you can imagine that taking what works in the lab to an oceanographic environment is often throwing up some amazing and very interesting problems. So that's about me. So what about this presentation? Well, I'll give you a brief overview of the course, and then I will go on to try and explain why somebody should choose this particular master. And then I will give you an idea of my ideal candidates, and then we'll move on to look at the syllabus and the modules, and we'll then consider the skills and the knowledge that you will acquire from this master, and we're going to look at the job opportunities once you graduate from this master. I will finish with how we deliver this course, and then a brief review of the application process, and I will then give you some feedback from our alumni. So, as David said, this is a typical master. It runs over 12 months. It's a taught master, which involves a 3-month research project. And the course is delivered by experts with international reputation in the teaching and research of electrochemistry. I'll tell you a little bit more about that later on. And the program involves a lot of theory, but also a lot of applications, and in particular hands-on modules. And essentially with this program, you get a blend of theory, fundamentals, but also practical electrochemistry. We have some modules which involve practicals with our instrumentation in our research labs. So why should one choose this MSc? Well, first, it's a unique program. There is only one MSc on electrochemistry and battery technologies in the world, and this is the one we give here in Southampton. And if you troll the net, you will only find 2 other MScs in electrochemistry worldwide. So there are very, very, very few courses that focus on electrochemistry across the world, and this one is the only one that combines electrochemistry and battery technologies. So why Southampton? Well, it's because Southampton has a very long history of doing research in electrochemistry. This goes back to the late 50s, early 60s. And as a result of that, we have a very large group of academics, both in the School of Chemistry, but also in engineering, and we collaborate. And between us, there are over maybe 10, 12 members of staff doing research in electrochemistry. We've been running postgraduate courses in electrochemistry for over 50 years. So we've got a long experience in delivering courses to MSc students, master students, and PhD students. But we've also been running the Southampton Electrochemistry Summer School in Instrumental Methods in Electrochemistry since 1969. And this is a 1-week course for people from industry and academia. And as a result of this course, we've published textbooks. So this particular textbook on the right there is the one that came from the lectures that we deliver in this electrochemistry summer school. And there are other textbooks that have come from colleagues here in Southampton. So it's a very unique environment to study electrochemistry and to practice electrochemistry, with strong links with industry and other departments here in the university. We collaborate a lot with physicists and material scientists, with engineers. I collaborate with mathematicians and with oceanographers because of the sensing work that I do. But the other reason why you should consider this program is because currently there's a huge demand for scientists and engineers to undertake R&D, research and development in energy storage and conversion. And basically, the industry doesn't have enough qualified people with expertise in electrochemistry. And this, therefore, is a good time to undertake this this program. So what is the ideal candidate? I said I was the admission tutor for MSc programs here in the School of Chemistry, so I review all the applications. And for me, the ideal candidate for this program is somebody with a previous degree in chemistry or a related subject. And I take a very broad view about related subjects because electrochemistry can have applications in biochemical environments, but also in medicinal situations for sensors in particular, but also in engineering. So I'll be looking for people with skills in maybe in electronics or in physics or in some form of chemistry. It could be environmental chemistry, it could be biochemistry. I'll be looking for people with skills in material science, because of course with battery materials and all the catalysts that we use on our electrodes, we need a lot of knowledge and expertise in material science. But I would also look at candidates with a background in polymer science. So I really try to find candidates with a strong background in all the STEM subjects, so science and technology in particular. But I will also look for people with professional expertise. So I've taken candidates who didn't have much chemistry or material science, but they ended up doing research projects which were very much related to batteries or battery management or development of catalysts for fuel cell electrodes, for example. So I take into account the professional experience, even job experience. And of course, I look for candidates who have a strong interest in electrochemistry, but also in renewable energies, whether it's to do with the development or implementation of renewable energies, and in particular in energy storage and conversion, and also material science, because the electrodes, the electrolytes, the separators, they all involve materials with very different properties. So material science is an important part of this program. So it's good to have an interest in this. What about the syllabus? Well, as I mentioned already, we have a blend of theoretical modules which will focus on electrode reactions and techniques, electrochemical techniques, and also obviously on batteries. So these will cover the fundamentals, but also applications. You'll be looking at comparisons between different technologies, for example, different battery technologies or different techniques to analyze battery materials. And then we have a strong element of practical electrochemistry. So we have two practical modules. One is called, one focuses on electroanalytical techniques, and the other one is focusing on application of these electroanalytical techniques to battery characterization. So characterization of an anode, of a cathode, or of a whole battery. And of course, there is the research project. So the research project starts in January. From January to June, you do the background literature, you talk to the project supervisor, but you don't actually carry out any practical work. The practical part of the project starts at the beginning of June and runs full time from June to mid-September. And the research project is basically done in our research labs with all the research facilities that we have here in the electrochemistry group. So the modules are as follows. We have a couple of modules on the fundamentals of electrochemistry and electrochemical reactions. And we have a module on modeling and simulation. So this is computational techniques to simulate electrochemical processes, whether it's just at one electrode or a full electrochemical system, a full reactor, for example, with flow, without flow, all sorts of situations like that. We want our students to be able to write their own basic computer simulations of an electrochemical problem, but we also teach them how to use commercial systems, commercial software, which are very popular nowadays to model electrochemical processes. We have a practical module I mentioned on techniques in electrochemistry, then another a battery and materials characterization module. We have a theoretical module on battery technologies and their applications. So this is looking at the different chemistries that people have used to develop batteries, rechargeable batteries, primary batteries, redox flow batteries, small scale, large scale systems. And then we look at applications. So we look at what defines the lifetime of a battery, what are the conditions to operate a battery to maximize the lifetime, conditions to avoid, to prevent damage to the battery. We look at battery management systems. We look at selecting the right battery for a given application. You can imagine that if you are designing a battery for a cochlear implant or for a pacemaker, it's not the same requirement as designing a battery for an electric vehicle or for a load leveling for a power station, for example, or for a backup power supply for a hospital. So there's a lot, you have to understand the chemistry, because from the chemistry, you have different battery technologies, and from that you have different applications. And then when we have an application, we try and compare different battery technologies, because some are not too dissimilar, but then you have to take into account the cost, or the full operational cost over the whole lifetime of the battery, and then you may end up choosing a different battery technology if cost is the main concern. We have a module on scientific writing and presentation skills. This runs over the whole 12 months, and it's there to help you prepare your literature review, to help you prepare your dissertation, to help you prepare oral presentations, which you will have to make during your project. And this is a compulsory module. In fact, all of the modules listed here are compulsory, except for the last one, which is an optional module, which you can take in any other chemistry postgraduate area, typically physical chemistry. So it could be, for example, X-ray diffraction or some spectroscopy. But you could also take an optional module offered by our colleagues in engineering, which would be more about energy and large-scale systems and solar farms and so on. So there is one optional module which you can choose either in semester 1 or in semester 2. In this program, we really want the students to develop skills and knowledge in an array of topics. Obviously, we really want the students to have a good grounding in the fundamentals and principles of electrochemical reactions. But we want people to be able to move on from that and develop their own models, because very often the mathematical models are very limited. So we want people to have the skills to develop their own simulations for the whole electrochemical processes. And we have a strong emphasis on the electrochemical techniques. We make a distinction between potentiostatic techniques and galvanostatic techniques. So potentiostatic techniques is anything where you control the voltage across the system, whereas galvanostatic techniques is situations where you're controlling the current that passes across the electrochemical system. And these are very important techniques because, for example, you're not charging or discharging a battery in the same way that you are investigating the properties of the different parts of a battery. And then we have other techniques that allow us to investigate different aspects of the battery without having to dismantle it. So you can imagine that when you have a battery with an anode, a separator with an electrolyte, and then a cathode, we would like to interrogate what happens at every interface within the battery. So you can imagine that the battery is like a stack of pancakes. Each pancake is an interface between a solid and a liquid, between a liquid and a porous material. And we need to be able to interrogate the electrochemical reactions which take place at each interface. We need to be able to interrogate the mobility of the ions as they travel from one part of the battery to the other. And for that, we have very specific techniques, for example, electrochemical impedance spectroscopy, which we really need to develop in that course, because the students need to have a good knowledge of these techniques, because later on in the practical modules, they'll be using these techniques to investigate battery materials. And also in their project, they'll be using these techniques to carry out the research project. So we put a lot of emphasis on electroanalytical techniques because they are used in industry, not just in research labs. When you are developing a battery, when you're developing a battery management system, for example, to monitor the life of a battery in an electric vehicle, your battery management system will be implementing some of the techniques, for example, small interrogations of the battery without doing full discharge or full charge of the battery. So techniques are very, very important in this program. We want obviously the students to have a good grounding and knowledge and the ability to apply their knowledge to the selection of battery technologies. Choosing the suitable technology for the application is a key part of this program. But we also want our students to have a strong understanding of the figures of merits, which determine the properties of a battery. For example, energy density and power density, Ragun plots. These are very important in research and development, but also in the use and the management of batteries later on in the job. For example, we're very keen on operational window, which is basically the window of potential and temperature where the battery can operate safely. So it's really essential to understand what determines this operational window. And that's very much to do with the stability of the materials, with temperature, with all the chemistry that takes place in these systems. So these are the skills that all our students acquire over the 12 months doing the modules, the theoretical modules, but also with the practicals and the project. So what are the job opportunity when you graduate with this program? Well, essentially, it's energy storage and conversion, because there's a strong emphasis on batteries, on fuel cells, on redox flow batteries. We also investigate supercapacitors and hybrid systems, which are a mixture of capacitors and batteries. We also consider electrolyzers, which are an essential part. Fuel cells and electrolyzers are really essential to the hydrogen economy and the renewable energies, like using the electricity coming from solar farms and wind farm. The job opportunities are strong in design, characterization, and management of batteries, obviously, because you have the right background for that, but also in materials development. There's a lot of research and development going into materials, designing new materials, nanostructured materials, for example, which have the right properties. We're trying to move from liquid or gel type batteries to solid state batteries, which can charge much, much faster than the conventional batteries. So you need to have scientists and engineers capable of developing the next generations of batteries. But there are a lot of opportunities in further studies. So PhDs in electrochemistry, in fuel cells, in catalysts for fuel cells and electrolyzers, but also development of electric vehicles, material science and electroplating, But other areas which involve electrochemistry, I didn't mention corrosion, but corrosion is a huge area where we need electrochemists to understand what's happening at the interface between different metals and between the metal and the environment, for example. And then sensors. We do have students going into sensors, in particular medical sensors. So, for example, the blood glucose sensor to monitor diabetes is a very advanced electrochemical sensor. Millions of people worldwide are using this sensor every day. And I teach the chemistry and electrochemistry involved in the development of these blood glucose sensors. And people have no idea about the amount of research that has gone into the development of this particular sensor from the 60s to now. We must be on the 9th generation of sensors. And so there's a lot of job opportunity in sensor development there. On the right-hand side, I've listed some of the companies that have taken our students. Some are sensors like Nanopore. Ilika is a battery technology. Nexion is batteries. Dyson, although Dyson is a manufacturer of vacuum cleaners and so on, they also have a strong R&D in batteries because a lot of their systems involve are handheld and require portable batteries. But we also have CT Technology, for example, which is a sensor development company. MIP Diagnostics, also using electrochemistry for sensing. Oxys Energy, that's batteries. And basically, a lot of our, most of our alumni have gone to jobs in these areas, but also into PhDs. I think about 2/3 of our students have gone on to take PhDs, to study for PhDs. So the course delivery, well, it's very much the same as what David presented, so I'm not going to spend too long on that. I just focus on a little bit on the assessment. So the taught modules are assessed with a mixture of coursework and exams. Some modules are entirely assessed on coursework, and most of them is a blend of exams and coursework. The project, there it's assessed in different ways via progress reports, oral presentations, and the dissertation. To pass a module, you need to achieve a minimum pass mark of 50%, and to pass the whole program, you need to achieve a minimum 50% overall across all the modules, and you need to accumulate 180 credit points. The lecturers I mentioned before, these are their names, just to give you an idea of the international reputation. So Phil Bartlett is the past president of the International Society of Electrochemistry. This is a body of about 4,000 research scientists in electrochemistry in the world. Andrea Russell is vice president of the International Society of Electrochemistry at the moment. I'm currently the chair-elect of Division 1 of the International Society of Electrochemistry. So we have 2 emeritus professors, Derek Pletcher, who wrote 2 of the books that I mentioned before, and John Owen, who they're both still very active in research. So we have these are just those in the School of Chemistry, part of the electrochemistry section. And as I mentioned before, we have colleagues also in engineering who are more involved with scaling up electrochemical processes to make large-scale batteries or large-scale fuel cells. The application process is fairly simple. You submit your application online with a CV, with transcripts of grades from your previous degrees, with certificates of grade. And also, if required, you upload your certificate to prove you have the right level of English language qualification to study here, to enter the UK and study in Southampton. We need 2 references. And if required, I will arrange for a 30-minute Skype interview with 2 staffs. And the idea there is to check fluency in technical English, because that's quite important for somebody to do well in all our courses, but also to discuss, for example, research experience or professional experience in electrochemistry, when there isn't enough from the CV or from the previous degree, for example. And we also want to check your motivations and your commitment. The feedback from our alumni has been very, very good. We have a very small cohort, usually between 5 and 10 students. So there is a strong cohort sense of belonging, and even with the pandemic, we have managed to maintain a strong cohort. And our students have been very, very pleased. Apart from the odd UK student, all our students are from overseas, and they come from China, from mainland Europe, from the Middle East. We've had 1 or 2 from India in the past, but it's a very much international cohort, very small cohort, and their feedback has been very, very good, and they keep in touch with us still now after they graduated. So this is the summary slide, if you want, which gives you the key points of this particular program, and I'm happy to take any questions as we move into the Q&A session now.
Thank you so much, Guy and David, for the knowledgeable presentation. So we are moving towards the Q&A session right now. The first question I'm taking over. The first question student want to ask, can I enroll myself in MSc Biomedical Engineering? Is any work experience needed?
No work experience is needed.
Thank you, David. The next question, is it relevant for a student who is about to start graduation from India, and how much it will cost to have a complete program in Southampton University? The student basically wants to say he wants to do the graduation and the master's in the same course from Southampton University. Then what is the cost for all 5 years, 5 to 6 years?
So in biomedical engineering at the moment, we have a undergraduate degree run out of the electronics department. And that is a 4-year MEng degree. So it's an integrated master's. So you don't get a bachelor's, you go straight to the master's. So it's rather, normally we either can do 3 years of bachelor's and then 1 year of master's, or with these MEng programs, you do 4 years and you get a master's at the end of that. So currently we have the MEng in biomedical engineering run as a MEng program. You could potentially also do a 3-year undergraduate degree of one of the other engineering programs, so mechanical, electronic, etc., and then add on the master's in Southampton also. So you've got the 2 choices, either 3 years plus 1 year, or the 4-year program.
So I'm not sure if there is a question also related to chemistry, but so for us it would be the same. We have the 3+1 essentially. So you could do a bachelor in chemistry and then join the MSc program, but that would end up with 2 degrees. And for the cost, for the second degree, the University of Southampton offers a discount. I think it's 10%. So alumni basically can do another degree here in Southampton with a discount. So I think that would be the case in both David's and my situation.
Thank you, David and Guy. The next question the student want to ask, what is the criteria for scholarships?
Guy, over to you.
Okay, so we don't have scholarships for MSc programs. Okay, all our students have either been sponsored by their government or by their company or by who have been self-funded. So we don't have scholarships to offer for this MSc program.
Thank you, Guy. The next question: can I apply to more than one program at the University of Southampton?
Yes, there is nothing to stop you from doing that.
Thank you, David. The next question: is there any new rule for the post-study work visa?
Hi, should I answer this?
Yes, please.
Hi. So with post-study work visa, it's now called the graduate immigration route. So students who study on a PhD will be entitled to apply for a 3-year post-study work visa, basically a graduate immigration visa. And students who do a 1-year master's will be entitled to apply for a 2-year post-study work. And you can do that work in any area. However, some students, from India this year will have gone on to be sponsored, so have not gone through the graduate immigration route, and they've been sponsored by companies. So they've taken them on and covered the whole cost of that.
Thank you, Donna. The next question: do you have any course on global challenges for sustainability?
I think in the School of Engineering, there is a program on sustainability, but I don't have details on that. I know some of our optional modules can be taken in this area, but as a whole program, I don't know. I can't speak for that.
So we have 4 programs in sustainability. One which is offered by the Faculty of Social Sciences and is more of a social science program, and then we have one on energy resources and climate change, energy, buildings and environment, and energy and sustainability with electrical power engineering. So those are the sustainability programs that we have.
Thank you, Donna and Guy. The next question: hi, I'm looking for Masters in Education program in UK. Please advise the option. Also, what are the career opportunities after Masters of Education program?
So I would like to just bring in Aravind here, not because he's done an MSc in Education. What I would like to do is leave my email for the student who's talking about education. Aravind is doing Biomedical Engineering. He's one of our students currently. I wondered if you'd like to unmute yourself, Aravind, and just let us know, give us some insight into your experience at Southampton.
Hi, my name is Aravind. I'm from India, Kerala. I did my undergrad program in mechanical engineering back in India. Currently, now I'm doing my master's here in Southampton in biomedical engineering. So far, it's very pleasant and it's very satisfying, the course. I'm almost done with my first semester right now. I'm looking forward to my dissertation next 3 months. So far, it's very good.
Thanks, Aravind. Would you be able to share my email with the MSc Education student?
Sure.
We have a webinar in a couple of weeks on the program, so it might be. I'd love to be able to share that.
Okay, sure. I'll share the details with the student. The next question. The student want to ask, I have completed my bachelor's in mechanical engineering. Is there any scope for me to apply for MSc Electrochemistry and Battery Technologies?
Can you repeat the question, please? I didn't catch everything.
Okay, am I audible now?
Yeah.
Okay. The student want to ask, I have completed my bachelor's in mechanical engineering. Is there any scope for me to apply for MSc Electrochemistry and Battery Technologies?
Okay, got it. I would say that the student has a good background in physics and mathematics, which is quite important because there's a lot of that going on in electrochemistry. But I would like to look at their modules to see if they have done some material science, or if they have studied some maybe chemical engineering or something like that, or maybe they have some relevant research project in the area of batteries, for example. So I would consider the application, but I would carefully look at all the modules, just to see that, to make sure the student has the relevant background to succeed in this program.
Thank you, Guy. The next question. What are the career assistance and opportunities during the course and after completing the course?
Okay, so I actually am a volunteer career mentor. I work with the Career Centre. I'm working in the international office. During your study and before you come to the UK, one of the things that you will get is you can register with the Career Centre. I always recommend that students do this on quite an early basis of coming to the UK. And also we have career fairs, both virtually and I hope in the future face-to-face, which gives students an opportunity to meet potential employers. Plus, the Career Centre will help and guide you with your CV, with your application process. They do a lot of workshops on all the different stages of the application process for graduate jobs, and also for, if you've got work experience, some students go straight on don't need to do placements or internships. So we really do provide a lot of support at Southampton to students. We understand that we try to equip you with all the knowledge you need to apply for jobs and to apply for placements. It is, things like that. We support you, we give you all those, the things that you need, and hopefully most students, apply for a lot of jobs, get interviews, and learn how to move on to the next stage in their career.
Maybe I can also add that as academics, obviously, if we know of opportunities, then we will provide you with support. I know of one of our students, at least, who did an internship at the hospital after doing her degree to gain some more experience and improve her chances of getting a PhD or getting a PhD place afterwards. So yes, we do what we can. And we have lots of links with industry, which is obviously helpful.
Thank you, David and Donna. The next question. What is the career opportunities after the Masters of Education? Oh, I have taken this question, sorry. The next question. Sir, I am MSc in Molecular Biology and Biotechnology. Will I be eligible for PhD in Electrochemistry or Biosensor Development?
For a PhD, this is very different. The application is done directly with the supervisor. So we do have some research in bioelectrochemistry, where we are, I have a colleague who is trying to develop the little mini fuel cell that can be implemented in the body to try and power a sensor inside the body. And for that, you need to develop some electrodes that can harvest the energy from the body. And that is quite a complicated challenge. It involves modification of electrode surfaces with some chemically appropriate layer. And so that we do have, but it's limited. And the application would be sent directly to that supervisor. You would have to apply directly to that person. If you're interested, the person is Professor Philip Bartlett. He was the top on the list I mentioned. but he's the only one who's working in bioelectrochemistry. But for PhD applications, it's not the same application process as for undergraduate or master courses. For a PhD application, you apply directly to the person you want to do your PhD with.
Yeah, and I think in terms of sensing, there are people in other bits of the faculty who work on sensing. There's Howell Morgan's group in electronics who does a lot of work on sensing, or Cesar Neo who does other parts of sensing. So I think you'd have to look at the website to see who are the people who are working in that sort of area. I'm happy to help with trying to identify a few people.
Thank you, David and Guy. The next question: do we need to submit a personal statement, SOP, along with the applications? What are the job prospects in the program Sustainability MSc?
Okay, so I think this is you do have to do a statement of purpose. You also need LORs, so you need your SOP, your LORs. You will also need an English language test, or you would need something like an MOI, which states that you were assessed and taught in English. So that's the things that you need to know really for your application. If we're looking at the sustainability, the Faculty of Social Science course, then there are a lot of different areas that you can move into, because you do things in geographical information systems, or you also do things in the population and consultancy. So there's lots of different areas that you can go in, independent on what course you're looking at. If you're looking at power and sustainability, and you go into the electrical power industry, then you're talking about a range, and a totally different range of careers, including consultancy. So I think it also depends on your background, what you studied at undergraduate, and what you also bring to the course yourself. I hope that helps.
Thank you, Donna. The last question: coming September 2021 in UK, taking blended learning classes or on campus?
Well, from June, the university, the MBA has been online, been face-to-face since mid-April. We're coming out of lockdown, and I think our courses are moving more face-to-face. I think that David and Guy would agree with me that we would hope to continue this.
Yeah, I mean, in chemistry, we started face-to-face teaching round about the 8th of March, because being a practical subject, we were allowed to resume face-to-face teaching. So I was teaching small groups of students face-to-face from March onwards.
Yeah, we've been teaching face-to-face since after Easter, end of April onwards. For some practical classes, they were running even before then. From September onwards, I would certainly expect almost everything to be face-to-face. But I think with probably an improvement compared to what we did before, by having more pre-recorded material also in addition to the face-to-face work.
I mean, I think it's fair to say that we are preparing for all eventualities. So we want to deliver the teaching face-to-face, but we are also prepared to deliver blended learning if required. And we've now been doing that for a year. So we've got, as David said, we have improved a lot our material and our delivery. And I think we are much better at it than we were a year ago. And I think the students have been very positive. The feedback we've received from our current students has been excellent, both at undergraduate level and master level. They've really appreciated the efforts that the academics have put in to carry on teaching despite the situation and carry on teaching to a high standard. I think that has been, we've been really overwhelmed by the feedback we've had from our own students.
Thank you everyone for joining us today and giving your valuable time to us. Anything else you want to put forward to the students who are watching us right now?
I guess just to say good luck with exams you might be taking and with choices you are making, and wishing you all the best. And I hope we will see some of you here in the not too distant future.
So what I would add to this is feel free to contact us if you have very specific questions regarding these programs. We're very happy to respond to emails, and we can even organize a Skype calls as well. Good luck, and thanks for taking part.
Thank you.
So we are now ending this session here. Thank you everyone. Take care. Bye-bye.
Bye-bye.
Bye-bye. Thank you very much.